Hello, we're back with another episode of Math Algo, tackling the world's hardest puzzles. Let's jump into the first puzzle. Here's the setup for puzzle 1. We see a square, each side measuring 10 units. Next to it, there's a rectangle, but with a cutout section inside it. The full dimensions of the rectangle are 12 by 9, and the cutout area in the center measures 1 by 8. Now, here's how the puzzle works. Make 2 cuts through the wooden piece so that the resulting pieces can completely cover the square. Each cut must start at one edge and end at another edge, any edges. The cuts can be in any shape you like. All right, let's start solving this puzzle. Do you want to try it yourself first? If so, pause the video and give it a shot. Let's continue. Our square with side 10 has an area of 10 by 10, equals 100 units. The rectangle is 12 by 9, 108 units, but it has a cutout of 1 by 8, so we subtract 108 minus 8 equals 100 units. That means the total area matches the square exactly, no more, no less. To begin, we divide the shape into a 1-unit grid. Now we make the first cut in a zigzag pattern, as you can see. Then we make the second cut the same way, but from bottom to top. Now we've created 2 separate sections, one similar to the right side and one like the left. We separate the 2 pieces, move one up by 1 unit, and then connect the 2 like this, and it's done. A perfect square that precisely covers our square. And that's the solution to our first puzzle. Now leave a comment and let me know. Did you understand the solution? All right. Let's move on to puzzle 2. We've placed 8 coins on the table, 4 coins in one row, and the other 4 placed just below them but shifted horizontally by half a coin. Here's the challenge. How can we move only 2 coins so that every coin is touching exactly 3 others? We want to find some kind of balance where each coin touches exactly 3 others. Let's start with these 2 coins. We'll take them out from the rows. Now we have 2 groups. But in this setup, some coins are touching 3 and others only 2. So this doesn't work. Let's put them back in their original position. Ah, look here. You need to place these 2 coins on top of 3 other coins in a way that forms this shape. Now check it out. This coin touches 2 below and 1 above. And this upper coin touches 3 coins below. Puzzle solved. Now on to puzzle 3. I'm going to show you a sequence of numbers. The first is 1. Then comes 11. Then comes 21. Then comes 1, 2, 1, 1, and so on. The question is, what comes next in this sequence? At first glance, it's super weird and makes no sense. But there is a way to solve it. You just need to say the numbers out loud. Let's go step by step. First, 1. You say 1, 1, that gives you 11. Then, 11, you say 2 ones, that gives you 21. Then, 21, you say 1, 2, 1, 1, that gives you 1, 2, 1, 1. Next, 1, 2, 1, 1, you say 1, 1, 1, 2, 2 ones, that gives 1, 1, 1, 2, 2, 1. After that, 1, 1, 1, 2, 2, 1, you say 3 ones, 2 twos, 1, which becomes 312211. So the next number in the sequence is 13112221, or 13112221. And that's it. Ready for Puzzle 4? We have 6 matchsticks. What's the challenge? Using these, you have to create 4 equilateral triangles. You're even allowed to use glue. At first glance, the number of matchsticks seems to suggest that we can't build more than 2 triangles. So what's the solution? The trick is, don't look at it in 2D. You have to imagine it in 3D. So how do we do that? Simple. Arrange the matchsticks into a tetrahedron. A tetrahedron has 6 edges, which perfectly matches our 6 matchsticks. And it has 4 faces, all of which are equilateral triangles. That's the solution. Stop thinking in 2 dimensions. Look at the puzzle from a 3-dimensional perspective. And now, Puzzle 5. We have 4 matchsticks arranged in the shape of a cup. There's a coin placed inside this cup. The challenge is move only 2 matchsticks to get the coin out of the cup without changing the overall cup shape. In other words, after your 2 moves, the cup should still look exactly the same. So how do we do it? Here's one solution. You slide out the bottom matchstick of the cup and reposition one of the side sticks. Then you complete the cup again in a way that lets the coin escape. That's a logical way to solve the puzzle. But there's also a more creative solution. You gently push the right matchstick toward the left until it reaches the coin. This matchstick pushes the coin to the left, toward the left matchstick. Keep pushing until the right matchstick ends up where the left one was. Then take the left matchstick that was removed and place it where the right one was. Now, the cup looks just like it did originally, but the coin is out. That's another valid solution, isn't it? And now, the final puzzle of the day. Puzzle 6. We have 4 matchsticks placed side by side in this specific arrangement. The challenge is, by moving only 1 matchstick, create exactly 1 square. At first glance, it seems impossible. It feels like you need to move at least 2 matchsticks to make a square. But look a bit closer. With just 1 small move, you can slide a matchstick upward and suddenly a tiny square appears right in the center. Let's take a closer look. The way these 4 matchsticks are arranged, there's a square hidden in the middle. And we created it by moving only 1 matchstick. So, how many of these puzzles did you manage to solve? Let us know in the comments. And by the way, don't forget to subscribe so you can catch our upcoming videos and shorts. Thanks for being with us.